Hello, my name is Dongjin Kim from Busan National University. The title of the presentation today is Classification of Main Accident Types in Maritime Accident using Grade Relational Analysis. Here is the brief summary of the content. Before the talk of our main topic, we show some of the photos and statistics of maritime accident to give an idea of why and how our research was initiated, and we proceed with our study and show the findings. It is the tragic capsizing accident of a Sewol-ho ferry occurred in April 16, 2014, where over 300 innocent lives were lost with economic damage of $3.8 million. Most of the victims were high school students on board. Major causes of the accident were overloaded cargo and unsafe operation of the ship. Another maritime accident is the collision of an oil tanker and a crane on a barge, resulting in the spill of a huge amount of oil and devastating environmental damage of around $6.5 million. The graph on the left side shows the number of accidents for the last 5 years from 2013 to 2017, where the number of accidents in 2017 was more than doubled compared to the accident in 2013. And as shown on the right side of the slide, the pie chart shows that fishing vessel accidents take up around 68% of the total maritime accident from all ships, which shows the objective of our fishing vessel investigation. Maritime accidents are less frequent than other industrial accidents. However, when an accident occurs, it not only results in the loss of human lives and physical damage, as shown in the previous slide, but also often leads to negative consequences towards weakening national competitiveness. Again, the maritime accident statistics show that the fishing vessel accident account for around 70% of the total accident, though the government provides a national level plan to prevent maritime accident. The numbers have been increasing over the past years. Since researches on fishing vessel accidents have not actively done, unlike other ship cases, we in the study identify the main types of fishing vessel accident into categories: frequency and fatality, using grade relational analysis, which is an efficient ranking technique to determine influencing accident types. The types of accident we consider are collision, touching, sinking, capsizing, fire, safety precautions, engine failure, grounding, and others. This slide shows 4 accident types, that is collision, sinking, capsizing, and fire. This slide shows the accident of a fishing vessel accident during the last 5 years, with steadily increasing trend, where engine failure and collision are shown to be 2 major accident types in number or frequency. For the number of fatality, the injury has been dramatically increasing, while the deaths and missing have not been changing greatly in numbers. For more accurate number of the fatality, we include injured and missing persons who are converted into fatality equivalent. For our analysis of fishing vessel accident, we use the 9 accident types from the Korean Maritime Safety Tribunal, or KMST in short, over the period of the last 5 years from 2014 to 2018. Most of the researches on fishing vessel cases occurred in Korean waters use only primary accident data from KMST, based on which measures to enhance safety are suggested. Since the accidents are classified into different categories, previous studies mainly focus on analysis of specific type or types, causes of accident, and corresponding accident mitigation measures. Also, risk assessment methods were applied to calculate risk level for each accident type and propose diverse measures to reduce potential accident. Usually, the statistical method needs a great amount of sample data. On the other hand, the grade relational analysis, or GRA in short, requires less data and analyze many factors that can overcome the disadvantages of a statistical method. In the study, we rank the 9 accident types leading to accident with GRA, which is widely used technique when data available is not sufficient and uncertain. Unlike other existing researches, GRA approach we employed in our study is to find similar or dissimilar relations between various variables of accident. GRA is a useful tool to determine ranking of alternatives in decision making. The method quantifies all influences of various factors and their relation, which is handling the relation between variables. The relational grade, or GRG, in short, obtained by GRA is to describe the relationships among the factors and to determine the important factors that significantly influence some defined objectives. Therefore, using GRA, one can easily rank the main factors using dependent and independent vectors or variables. 5 basic steps we employed for GRA are determination of reference sequence as your benchmarking sequence, normalization of original data, calculation of a grade relational coefficient, or GRC in short, calculation of a grade relational grade, or again GRG, and finally determination of a ranking of each accident type of fishing vessel accident. The accident with the highest GRG is the most influencing accident type. Based on the procedure outlined here, we perform GRA for fishing vessel accident and identify main accident type which causes accident. First, we calculate the influencing accident type using frequency data. Based on the fishing vessel accident data from KMST over 2014-2018 period, frequencies of 9 types are summarized in the following table 1, where the 9 accident types are independent variables and accident frequency is the dependent variable. The numbers under the accident frequency column form the reference sequence. Here, COL represents collision, TOU is touching, GRO is grounding, CAP is capsizing, FIR is fire, SIN is sinking, ENG is engine failure, SAF is safety precautions, and OTH is others. After normalizing the original frequency data, we obtain the following GRCs in table 2 here for each year. As the GRC gets close to 1, the corresponding accident type has more influence on the accident type. Accident occurring. For instance, the GLG for collision over 5 years are shown in figure 1, and GRCs for other accident types are shown in figure 2 here. Okay. It's showing in figure 2 accident types of collision, engine failure, safety precautions, and others have a relatively higher coefficient than other types. The grade, relational grade, or GRG, for each accident type is obtained in table 3. From the table, we see that engine failure is ranked first with the GLG of 0.9114, followed by others and collision, whereas touching and sinking are shown to be the least influencing accident types. The GRGs for accident types are shown in figure 3 here. Secondly, we calculate main accident types using fatality data. The injured and missing people are converted into fatality equivalent by assigning proper weight to the death, injured, and missing, which are 1.996 and 0.043 respectively. The resulting fatalities of each type are shown in the following table 4. The calculation procedure for GLA is similar to the case of frequency, and the results are shown in the following tables and figures. GRCs for all types are presented in table 5. For instance, GRCs for collision for 5 years are shown in figure 4, and GRCs for other accident types are shown in figure 5. From the above table, figure 5, collision, grounding, capsizing, and safety precautions have higher GRCs compared to other types, whereas touching, engine failure, and others have lower coefficient. The GRG and the ranking for each accident type are presented in table 6. Safety precautions is the most influencing type with GRG of 0.9148, followed by collision and grounding, whereas engine failure and others are the least influencing accident types. The GRGs for 9 accident types are shown in figure 6 here. Let me go to the next slide. GRGs for frequency and fatality are compared and presented in figure 7, where vertical blue bars represent frequency and red bars represent fatality. collision and safety precautions have higher GRGs in both frequency and fatality, showing that they are major influencing types in fishing vessel accident. Based on the difference in GRGs for accident frequency and fatality calculated from GRA, the following Table 7 shows GRG ranges within which the accident types are grouped, where GRG for safety precautions and collision are over 0.7. Touching is a less influencing type in both frequency and fatality. The Table 8 shows ranking changes between frequency and fatality. Engine failure and others have the biggest difference in ranking changes from the most influencing types in frequency 1 and 2 to the least influencing ones in fatality, ranking 8 and 9. The ranking changes between frequency and fatality are shown in Figure 8, where the vertical axis represents the ranking. The average of the two GRGs for each type are calculated and presented in Table 9, where collision is the most influencing type with average GRG of 0.8423, followed by safety precautions, while sinking and touching are the least influencing types of accident. Now, we wrap up our presentation by summarizing the result and mentioning a bit about the future research direction. For the establishment of a maritime accident mitigation policy, one needs to classify the major types for accident. In the study, we, using grade relation analysis, identify the most influencing accident types for fishing vessel over the period of 2014 to 2018. For frequency case, engine failure, others, collision, and safety precautions were the most influencing types, whereas touching and sinking were shown to be the least influencing accident type. For fatality case, safety precaution and collision were the most influencing accident type, whereas touching, engine failure, and others are the least influencing accident type. Finally, for the combined case, that is the average of frequency and fatality, collision and safety precautions were most influencing types, whereas fire, sinking, and touching are the least influencing types of accident. Therefore, the results show that collision and safety precautions should be paid more attention, among others, in reducing maritime accident. For the study, we only considered the fishing vessel accident. However, to get more confident result on influencing types of accident, we need to broaden the scope of the study to include other ships accident, such as oil tankers, container ships, passenger ships, and bulk ships. Also, for the future decision of the research, for the future direction of the research, major accident causes should be considered in future research to establish and implement necessary accident reduction measures. Thank you for your attention.